Hi everyone, welcome in another video, Encoding versus Embedding, which one posts machine learning accuracy. Follow up with a practical example in Python and Kaggle dataset. Let's get started. First, let's define feature engineering and highlight the main purpose. So basically, feature engineering helps to transform the raw variables, aka the database columns, into meaningful data. This data will be used later to train machine learning model. As you can see in the table, we have ID, age, education, years of experience, marital status, and salary. Salary here represents the target response, the column or the variable that we want to predict if we will apply a regression model here. Variables are numeric, except education and marital status. So we will apply feature engineering on these two columns in order to help us predict the salary. And I want also to highlight the end-to-end machine learning that starts with defining business problem, then build SQL queries and retrieve the data after the SQL, like running the SQL queries, and then we have the data understanding and data wrangling or data cleaning, then feature engineering. These are fundamental section or stages that we will do it in every machine learning project before the machine learning training model. Starting with encoding. Encoding is basically replace the text, the ABC or the categorical instance into numeric. Replace color blue and give it 1. Orange, give it 2, based on a certain sequence. And encoding has many types. We have one-hot encoding and ordinal encoding. These two are the most common and used techniques. And then we have label encoding, target encoding, and cyclical encoding. One-hot encoding, or one for short, is to convert the unique categorical values into binary columns. However, the only challenge with one-hot encoding is that it can initiate sparse dataset where most of the values are zeros, which will affect the model performance. A simple example here, if you look on the right side, we see a table that has apple, orange, watermelon, kiwi, dragon fruit, and pineapple. So basically, if we have like a grocery data set and there's one column that is fruits, for instance, and this column has these values, apple, orange, watermelon, etc., unique values, one-hot encoding will transfer all these unique values into binary columns, zeros and one. If we are using sklearn or the brute force method, we simply importing sklearn as following. From sklearn.preprocessing import one-hot encoder, and label encoding simply means assigning a unique numerical values to each category. Red is 1, blue is 2, teal is 3, but still it is inside the same column. We are not creating binary columns here. Okay, even if there is no inherent order among them. However, some machine learning algorithms, like linear regression or support vector machines, may incorrectly interpret these numeric values as ordered. And to avoid this issue early, we simply use tree classifiers or random forest classifier or regressor as a baseline model, because random forest algorithm fits both classification and regression projects, and also it can handle label encoded variable 1, 2, 3, this numeric values without any assumption related to any pre-specific order. So random forest algorithm is pretty flexible with parameter tuning and make fewer assumptions about the data. Make it a great fit as a baseline to explore the initial machine learning model performance before exploring more complex models. Another great example is ordinal encoding. Ordinal encoding is commonly used technique in feature engineering that assigns a meaningful order for the numbers to a categorical variables or categorical instant. For example, in loan status feature or variable, categories might be encoded as low risk assigned to 1, medium risk assigned to 2, high risk assigned to 3. This method should only be applied to features that have an inherent order or hierarchy, because it will help when we apply machine learning techniques such as linear regression. Applying ordinal encoding to unordered categories can mislead models into learning non-existent relationships. And finally, with the last one, cyclical encoding, sine and cosine transformers. Some features such as days, months, hours are cyclical in nature. That means their values wrap around in a cycle. We see that December is somehow close to January than December to June, for example. All right, so applying ordinal encoding can be tricky here because it implies a linear relationship that doesn't exist. And for this reason, cyclical encoding is much appropriate here. And I wanted to give you an example of the sine cosine transformers. So first we rely on NumPy library, and cycle is equal 7, that reflects the number of days in a week. Then we apply the weekday sine and weekday cosine, as you can see in this example. Pause for seconds to see it and understand it. Embedding simply acts as a smart navigator, assigning numbers to categorical values in a way that captures similarities between them. Unlike one-hot encoding, which treats all categories as equally distant, embedding can place related categories close together. And we often use embedding when we have 10 to 15 or maybe more unique instances in a variable. A nice example here, if we have in a dataset country column that has all the country names, so embedding can be a very useful technique here because it will group countries like UK, France, Germany, Belgium based on because they are geographic close to each other together. And it will also group countries like Ghana, Rwanda, and Kenya because they share similarity or the same geographical characteristics without explicitly transforming the data into continent. Embeddings provide a powerful way to present categorical data in a form that models can learn from more efficiently. Embeddings type, there are many types, but I just wanted to focus on word embedding, categorical embeddings for tabular data, that we have geographical embedding that we will focus on in our practical example. We have also user and items embeddings, and we will use user and items embeddings in recommendation systems. Then we have image embeddings. We will cover it later when we talk about deep learning techniques and methods. Moving on to geographical embeddings that deals with location-based information, city, country, postal code, using mapping and clustering techniques to group closed locations together. Pro tip here is that Kaggle has a free course about feature engineering. Feel free to check it out. And it covers feature engineering principles, clustering with k-means, because you might want to segment data points into groups. We have also PCA, which is a common technique in dimensionality reduction, and a bonus lesson to implement all these techniques and what you have learned on practical example, the housing prices prediction dataset. I will add the link in the video description. Now, let's practice. I want to highlight that the two approaches that will be present in my example is one, the brute force encoding, and the other one is using encoding within a pipeline. So I will use the dataset Kaggle Hotel Booking Demand, the link in the video description, and techniques, feature engineering, encoding, and embeddings, the techniques I covered in the video. And the next part of this video will be completely silent, no talking. However, I will fill the model with comments and doc strings. Feel free to drop your comment down below if there is something or anything not clear. I will happy to, and I will address all your comments. Thanks for watching. You now know how to implement the encoding and the embedding techniques efficiently. I hope you like this video. Feel free to like and subscribe for more data science content. The dataset and code are linked in the description, and feel free to try it out yourself. If you have questions or want to see another dataset in action, drop a comment below. I respond to all of them. See you in the next video. Bye.